We all know what advantages Apple got from designing their own CPU chips, an industry-leading combination of power, efficiency, and performance. Apple was able to attain this by being able to make all of the architectural decisions for their processor, how it interfaces to memory, and other architectural features of a computer hand in hand with the operating system. In other words, being vertically integrated has clear competitive advantages for Apple. Apple has those advantages because their CPU design team is competitive with anyone on the planet, and Apple will continue to invest to maintain this advantage. But do these same advantages accrue to having your own mobile modem chip? So far, the only visible advantage Apple claims is better power efficiency. For the iPhone 16e, that's using Apple's new C1 5G modem chip, although it's not as clear-cut as advantages of their own CPU chips, one can imagine that integrating a mobile baseband more tightly with the operating system could lead to power efficiency gains. On the other hand, one could also imagine leaving out millimeter wave capability could also lead to power efficiency gains. Unlike the M1 CPU chip for laptops, the C1 modem for mobile devices doesn't have as clear an advantage. I would venture to guess there's a lot of pressure on Apple's in-house modem team, just as the CPU team is competing against Qualcomm and perhaps a few other CPU makers. The modem team is competing against Qualcomm, MediaTek, and other 5G modem makers, even though it's not the central processing unit. The modem team's task is arguably more complex than designing an efficient, high-performance CPU, in part because of that complexity. Apple is already billions of dollars into the modem effort. But it's not just 5G modems that have a potential advantage if vertically integrated into a mobile device architecture. Mobile devices are full of radio receivers and transceivers other than the mobile radio for 5G, LTE, UMTS, HSPA+, GSM, Edge, and I've probably left out a couple other mobile standards. There's also radios for GPS, Bluetooth, Wi-Fi, UWB, NFC, Thread, and more. Digital radios have a lot of architecture in common, even though they are used for different purposes, and they have different performance characteristics. They all decode and encode the radio signal. They all have what's called a baseband. The baseband is what implements the protocols for a particular radio standard, like how many bits are in a packet header, and what do they mean. The baseband also enforces things like how packet collisions are handled, how you hand off from one cell to the next, how to pick the best channel, etc. That's what is implemented in baseband firmware, and it's different for each of these radio types. If you're getting the feeling there's mind-bending complexity in supporting the radios in a mobile device, you would be correct. Apple has made the strategic bet that taking on this complexity is going to be worth it. What Apple sees in that complexity is the potential for building competitive barriers and achieving performance and power advantages others can't access.